Welcome to Lesson Up, math tips, tricks, and other ideas. To help continue expanding this site, don't forget to subscribe and like. Expressing the use of counting techniques can sometimes be overwhelming for students. I simply convey to students that all we are trying to do is tally up an amount. But what is confusing for students is applying counting techniques in context. Consider this problem. A typical bicycle lock contains 40 numbers. If the combination contains 3 numbers, in which the second number of the combination must be different than the first and third numbers, determine the number of possible combinations for the lock. If you'd like to try this problem on your own, you should pause this video now. Now for me, a nice graphic of a bicycle lock works wonders when guiding students through the application of a problem. So encouraging them to draw a picture and place themselves into the event helps in understanding this scenario and adds clarity. Though they can be any numbers, suppose the combination for the lock consists of the sequence of numbers 30, 20, and 8. Now, according to their logic, students determine that there are 40 numbers that can make up the first number of the sequence. In this example, we use the number 30. And since the second number must be different than the first, they determine that there are 39 numbers left to make up the second number. Again, in this example, we use the number 20. And because the second number must be different than the third number, they determine that there are 38 numbers left for the last number of the sequence, in which we use the number 8. So for them, the counting is okay. Multiplying these values together suggests that there are 59,280 possible outcomes. But then I asked the students, suppose the combination was 15, 32, 15. Does this fit the description of the scenario? In other words, is the second number different than the first and third numbers? An aha moment is declared, and students recognize that the number of combinations has to be 40 times 39 times 39, because the third number can be the same as the first, correctly resulting in 60,840 possible outcomes. When students first read a problem like this, it's not ambiguous to them at all. The trouble they have is making a connection between the counting and the context. Reverting back to their initial response of 40 times 39 times 38, I asked my students what this amount represents. They successfully respond that it is the number of combinations in which none of the numbers of the bicycle lock are repeated. Now, I wanted to make sure that my students were being analytical and not just reactive, so I revised the problem. Rather than the second number has to be different than the first and third numbers, now let the third number be different than the first and second numbers. If you'd like to try this problem on your own, you should pause this video now. Now, too often students will reflexively respond 40 times 40 times 39. They rationalize that the first and second numbers can be the same. This results in 62,400 outcomes. When I revert back to their previous solution, in which the second number had to be different than the first and third numbers, the result was 60,840 different outcomes. So why would the number of possible outcomes be greater when the third number must be different rather than the second? Well, needless to say, they were perplexed. I asked them if there is any reason to believe that the amount of outcomes should change simply because another number of the sequence has to be different. Some students said yes, some said no, but none were confident on how to explain why. To me, it's best to explain to students logically what is occurring rather than mathematically. I told students, imagine they are going to come up with their own combination for their bicycle lock in which the third number of the sequence has to be different than the first and second numbers, except they have to assign a number first to the third number of the sequence and then work backwards. And wouldn't you know it, another aha moment. To help continue expanding this site, please don't forget to subscribe and like. Thanks for watching.